projectile motion. It's kind of the 2D equivalent of free fall. So it comes with some special conditions. And that is the only force acting on the system is gravitation. So if the only force acting is gravitation, we get some nice stuff for our acceleration vector. So here we have only gravitation acting on the system. And that means the acceleration in the x direction will be identically equal to 0 because no other forces and gravitation's pure vertical. And that the acceleration in the y direction will just be equal to minus g in terms of size, or negative 9.8 meters per second squared. Okay, that simplifies things out a little bit, because if we're writing our equations in terms of components, so x versus y, we just find that Vx is equal to Vx initial, because there's no acceleration in the x term, so nothing else will happen there. And in the x direction, a lot of these equations get very boring. So it would basically be Vx initial times t, no acceleration. The third equation looks identical because Vx initial is just equal to Vx. So those become very boring. The fourth one, also very boring, because delta x will just be equal to 1/2 Vx plus Vx initial times t, but these are equal to each other. So you can simply say that this interior part is just 2 times the initial velocity in x, which 1/2 and the 2 cancel. This will just be saying, same as the two equations above, that it's equal to Vx initial times t, or the final. The fifth one just ends up saying that Vx squared minus Vx initial squared is equal to 0. Like I say, the x component gets very, very simple to deal with. Basically, constant speed, because no acceleration. So whatever its initial launch speed is in the x direction, it'll stay that. All right, vice versa. The y direction gets just as interesting as usual. Vy final will be Vy initial plus our ay times t, which in this case is minus gt. Delta y will be equal to Vy initial times time plus, minus, because we have a negative acceleration, gt squared. Continuing on, the final times t plus 1/2 gt squared. Why plus? Well, because we've got the acceleration is negative, so a negative and a negative make a positive. All right, 1/2 Vy final, Vy initial, and t, and finally, to ay. I should write that in properly, so there should be a minus 2g delta y. So it simplifies the equations down, and you don't have to memorize these. What you do have to memorize is this relationship for what is positive and what is not. I'm going to change, oops, not that color. Ooh. Well, maybe I won't change that color after all. I was hoping I could just put it in after the fact, but alas. I guess I can go back one step and just circle it in yellow. This is the only part you really have to memorize. All right, there is a little bit more. The initial velocity is usually given as a magnitude and a direction. So just a little bit more and we'll be done with this section. That means you're usually told something like, it launches from an initial position, and you have some v at some angle, usually relative to the horizontal, but watch out, some problems give it relative to the vertical. If it's relative to the horizontal, then you can just use what's given here. Vx initial would just be equal to v cosine theta, and Vy initial would just be equal to that magnitude v times sine of theta. And remember, that's coming from looking at this triangle. We get Vx initial along here, Vy initial along there, and we're getting our V initial. I'm actually going to go back and put in the Vi. If you're given this in a different way, if you're given it relative to the vertical, be careful, because now you're splitting it into Vx along one side and Vy initial along the other. So notice that will flip the case. And again, you shouldn't be memorizing this. This is just coming from trigonometry. We're analyzing the triangle right here in green versus analyzing the triangle up here in green. So you should always just think about SOHCAHTOA and look at the triangle that's relevant. All right, so Vxi would be Vi sine of theta this way around, and Vyi would be Vi cosine of theta. So always watch, is it given relative to the vertical or the horizontal? Be careful. And always use your trigonometry. And if you need a review of trigonometry, I believe we posted one first week. Or if you're still having trouble, we can look at another one coming up later. Just let me know. All right, that's going to be it for this one, and I'll see you in the next video.